Good day everyone. My name is Richard Angelo Luzon from the Bachelor of Science in Civil Engineering, and for today we will solve a sample problem involving rolling motion. So the problem is, a car with tires of radius 31 centimeters drives on a road at a 70 meters per hour speed. So in this problem, we are looking for two unknowns. The first one is calculate the angular speed of the tires. The second one is calculate the linear speed of the tops of the tires. So we will answer that problem. In this particular problem, we are looking for two unknowns, which is the angular speed of the tires and the linear speed of tops of tires. The first one that we will solve is the angular speed of the tires. And there are two known values in the problem, which is the radius 31 centimeter and the linear velocity that is 70 meters per hour. So we know that the formula that we will employ to solve this problem is the linear velocity is equals to radius multiplied by the angular velocity. So in order for us to plug in the values and derive the equation that we will use, we must first convert the unit of the linear velocity because the unit is miles per hour. So to do that, we will factor it out. So we will multiply the 70 meters per hour to 1609.34 meters all over 1 mile, since 1 mile equates to this. And after that, we will convert 1 hour to 60 minutes. And after that, we will convert 1 minute to 60 seconds. And we will multiply all of this. And by calculating, we will arrive at 31.293 meters per second. We should also note that there are some unit cancellations that will occur, such as the miles, hour, and the minutes. The value that will be left out is meter all over second. So this is the derived linear velocity. So the thing is, we need to make this angular speed to the other side of the equation. So therefore, we need to have a transposition. And after the transposition, we will arrive in this formula, which is the angular speed is equals to linear speed or linear velocity rather all over radius. And plugging in the values, we will plug the 31.293 meters per second to the linear velocity, and we know that the radius is 31 centimeter. And by calculating, we will arrive at 100.95 radians. So this is the angular speed of the tires. So let's move on to letter B. So to find letter B, we just need to apply a principle. We know that in translational motion, there is a velocity acting at the top. We also know that in rotational motion, there is also a velocity at the top of the tires, and we know that the movement is going from here. Therefore, what we need to do is we will just double the linear velocity that we previously have in the problem in order to solve the problem. So therefore, the formula is 2 multiplied linear velocity. So we will just simply plug in the values in order to find the speed of tops of the tires. So we will substitute the 70 meters per hour and multiply it simply by 2. And we will arrive at 140 meters per hour. And this is the answer to letter B. We should also note that there are some cases wherein the value or the unit that you need to yield is given. Like for example, the unit that you must yield is meters per second. Therefore, once again, we need to employ this conversion in order for us to arrive at a meters per second unit. But in this case, it is not stated. Therefore, we are free to choose of what will be the unit of the final answer. Therefore, we arrive at 140 meters per hour.